Hi, my name is Willie Martin, and I am one of the instructors here at TrainACE. Today I'm going to be talking to you about the OSI reference model. Now, the OSI reference model is important because it's a theoretical model of how communications are handled end-to-end on a network. Now, it just describes how the data is going to be transferred from one device to the other using the 7 layers. Now, it is made up of 7 numbered layers, and this layered approach actually is very valuable because it helps you troubleshoot, and it also describes what is happening to your data as it moves down each one of these layers. Now, I must add that the layers must exist on the receiving system as well. And the OSI reference model is kind of like a standardization. This is the way data is going to be handled end-to-end on an internetwork. All right, so if the 7 layers exist on device 1, the 7 layers are existing on device 2, where the information is going to be received. Each device has the same layers. Okay. Now, understanding how data is sent end-to-end on a network also helps with your troubleshooting. Now, the 7 layers that we're going to be talking about, starting from the top to the bottom, would be layer 7 would be the application layer. Layer 6 is the presentation layer. Layer 5 is the accessions layer. Layer 4 is a transport layer. Layer 3 is the network layer. Layer 2, the data link layer. And layer 1 is the physical layer. Let's start with the application layer. Now, the application layer is responsible for integrating your network services that are running on a network. It's not an application. It just describes what services need to be supported on the lower layers. For instance, if I was looking for a web page, that means I need to have a web server supported. So it's telling the application layer is saying, I need a web server to be running on the receiving network in order for me to see a web page. Okay? Application doesn't refer to the application itself. It just explains what server services need to be supported by the lower layers so that the receiving device can display that web page. This is the layer that we see. The presentation layer is the next layer. Now, this layer is concerned with the syntax. This is where compression, decompression, encryption, and decryption take place at this layer. This is making sure that the data is going to be readable by the receiving system. Okay? They need to all be speaking the same language. Okay? If it needs to be encrypted to protect the information that's being sent, then encryption is going to take place on the sending device. The receiving device is going to be able to decrypt the data so that it can be presented to the application layer so that you can see or read what was in the message. The next layer is the session layer. Now, this layer is responsible for creating the session between the 2 communicating devices. It's responsible to start the session and end the session. Okay? It's concerned with the reliability, the integrity, and descriptive naming of each session. Now, each session will have its own session ID. This helps keep all sessions separate. It's going to make sure that information for one session doesn't get mixed up with another session, and so it's going to make sure that messages or any information that's meant for one system doesn't get sent to the wrong system. Once the session is over, it's responsible for ending that communication. The next layer is a transport layer. Now, this is responsible for the delivery of data on a network. Now, there are 2 types of protocols that work on a network, TCP and UDP. Now, Transmission Control Protocol, or TCP, is a connection-oriented, reliable delivery of your data. Okay? UDP, your User Datagram Protocol, is connection-less, unreliable delivery of your data. Now, TCP is going to guarantee that your data is going to be delivered to the correct device. TCP requires that each party, the sending party, has to identify themselves as the correct sender to the receiver, and the receiving device has to identify itself to the sender to make sure that, yes, this is the correct recipient of the data. And once this has happened, only then will the communication or the data be sent. If neither party, one or the other, can't be identified or certified that this is who they are, then the data will not be sent. Now, UDP is not concerned with that. Its main concern is just getting data sent through the network. That's it. Just point and shoot. It's not concerned about whether you're there, the receiving device is checking to make sure that who you are, say you are. When we think about UDP, think about streaming. When we're looking at music or listening to our music and watching movies on TV, etc. This is UDP. Some packets may be lost, but that's okay. It doesn't mean that it's going to stop and regroup. Now, TCP is connection oriented, so it's going to be reliable. So it's going to check and make sure if there's any dropped information or segments, it's going to request that the missing segments be retransmitted. UDP is not going to do that. Now, at this layer, the transport layer, your data is called a segment. That means your data is going to be broken down into manageable chunks that can be sent through an Ethernet network. The next layer we're going to be talking about is the network layer. This is where routing takes place. Now, it's responsible for moving your data between systems through an internetwork. Now, routing protocols or rules specify how your data is going to be sent through your network. The whole purpose of your router is to find the best path or the quickest path depending on what protocol you're using. Okay. The data at this layer is called a packet, and this is where your routers work at this layer. The next layer is your data link layer. This layer is responsible for the interfacing between your physical medium and your network layer. Now, this layer is really concerned about the logical topology of your network. In other words, it's not concerned about where the physical devices are actually located. It's more concerned about the path that your data is going to take to be received at the endpoint. Okay. Now, there are two layers that make up the data link layer. The logical link layer, okay, which provides that interface between the bottom and upper layers, and your MAC address layer, or your media access control layer. This layer is where your physical addresses are assigned. Now, each device on the network, your computers, your laptops, they have what we call a MAC address. That is an address that is hardwired into your network interface card. It's kind of like the VIN number on your car. The VIN number on your engine is unique for that engine. You can take that engine out and put it in another car, but the number doesn't change, just the body that it was put in. The same thing for your MAC address. Your MAC address is unique to that particular network interface card. No other network interface card has the same MAC address. And this uniqueness helps make sure that your data is going to be delivered to the correct physical device. Your data at this layer is called a frame. The last layer is the physical layer. Now, this layer is concerned with the physical hardware on your network as well as the physical topology. This is where we know where every device is located. Okay? This includes the rules or protocols that use to identify your connectors and devices that can be used on a network. Now, depending on the media that you use will determine the type of signal that's going to be used, what format it's going to be. So if we're using a copper wire, then the signal is going to be electrical impulses being sent through that copper wire. If we're using fiber optic cable, it's going to be pulses of light. If we're using wireless, it's going to be radio waves. Data at this layer is called bits. So in summary, today we discussed the OSI model and its purpose. We discussed the 7 layers that make up the OSI model, and a brief overview of how data is handled as each of these layers was discussed. That concludes our discussion of the OSI reference model. If you have any questions about the OSI model, reference model, or any IT training in general, you can call us at 301-220-2802, or you can email us at info@trainace.com, or you can find us on the internet at www.trainace.com. Once again, my name is Willie Martin, and I thank you for listening.